We're solving. So once again, crank your brain back to all the algebra that we've shoved in there in the last few years. So when we're solving, we're isolating the x. So once again, add the 7, 2 ln x equals 2, divide by 2, divide by 2. Oh my goodness, ln of x equals 1. Remember, ln is log base e. E to the first power equals x. X is e. X is e. Okay? X is e. There we go. Let's do another one of these problems that are on here. Let's just back up one and do number 25. Okay, I'm recording now. And I've got all these papers up here if anybody wants to grab them. So let's back up one and do 25, which is log base 16 of 9x plus 5 minus log base 16 of x squared minus 1 equals 1/2. So what do we have here? Well, we've got subtraction. The subtraction squishes together to be a quotient. So log base 16 of 9x plus 5 over x squared minus 1 equals 1/2. So now 16 to the 1/2 power equals all of that. What is the 1/2 power? 4. It's a square root. The square root of 16 is 4. 4 equals 9x plus 5 over x squared minus 1. And I see right away that I should set two fractions equal to each other, which I'm now going to cross multiply. So from there, 4x squared minus 4 equals 9x plus 5. This just turns into a handy little quadratic equation. So 4x squared minus 9x minus 9. Is this factorable? Yeah, I think it is. 4x, x, 3, 3, 12, 3, 9. There we go. So we end up with x equals negative 3/4 and 3. Those are the answers. Now, do both of them work? The negative 3/4 does not work. But why? Because 9 times negative 3, or what? Yeah, it would be a negative number. What is that? Negative 27 over 4, which would be negative 6 and some change. So negative 6 and some change plus 5 would be still a negative number. See, so the negative 1 is an extraneous solution. The 3 is going to work. All right? Look on the paper. Yell out another one. Quick, quick. Yep. Okay. Let's do, we'll just do 12 and 13 real quick. And just because we're going to be short on time and those fraction problems take a mother load of time for us to get through, I'm going to have to be as quick as possible on the logs.
Wait, so only 3 was possible?
Only 3 was possible, exactly. So if we have the common log of 25, and they're telling us here that log 5 is 0.699, that log 7 is this, so we're to evaluate, not using a calculator. This is the same as the log of 5 squared, so 2 times log 5, and then we do a quick substitution of 0.6990 and whatever 2 times 0.6990 is. That's all we needed to do there. Now for number 13, log of 10 divided by 7 is log of 10 minus log of 7. So that's log base 10 of 10, which don't miss that, it's 1 minus log 7, which is 0.8415. So whatever 1 minus 0.8415 is. So 0.1549, I guess, is whatever that is. Okay? So that I'm going to have to be brief on the logs. I'm just going to ask you kind of one of each, an interest problem, solve a couple of equations, expand, condense, and move on, because I've got to save you a solid 25 minutes to do a couple of fraction problems because they're monsters. All right, anybody else think of one? Because we need to, I got them ready to go, okay?
For the ones that are on that page, the 5 through 10, that is just, you put like 3 to 5x equals 81.
Yep. 3 to what power equals 81? 4. 9 to what power equals 1? 0. 2 to what power equals 1 over 16? 2 to the negative 4th. Here, 14 to the log base 14 of 6 is 6. This one, log base 10 of 0.001 is negative 3. This one, 2x. Okay, and yes, Jody, all those answers are online now. Okay, here we go. This one is just straight up a mess. We've got, first of all, lost my spot. Where'd it go? Yeah, this is nasty. Here we go. 4x cubed plus 4x squared minus 4x plus 2 all over 2x squared minus x minus 1. What's the very first thing that's necessary here? Long division, because the degree of the numerator is greater than the degree of the denominator. So we're going to go to long division. 4x cubed plus 4x squared minus 4x plus 2, and we're going to divide. So 2x squared times what is 4x cubed? 2x. So multiply through by 2x, and we get 4x cubed minus 2x squared minus 2x. Draw the line, change the signs. Cancel. 6x squared minus 2x plus 2. So 2x squared times what is 6x squared? Plus 3. Multiply through. 6x squared minus 3x minus 3. Draw the line, change all the signs. Goodbye. X plus 5. That's the important part, right? The quotient. The quotient is the important part. We're now going to bring that, remainder. Remainder is the important part. Quotient's important too. We bring that in the end. But the x plus 5 is now out of the divisor, and that's the part that we're going to decompose. Okay, what's the next step? Factor. Yes. Factor. 2x, x, 1, 1, minus, plus. Now, these factors are both linear. Yay! Okay, since they're both linear, all we need is an a and a b. So, a over 2x plus 1 plus b over x minus 1. This one could very easily be done with substitution. Let's do it that way. So if this is now our equation that we have to work with, let x be 1. If x is 1, it's going to cancel out that whole part of the problem. So 1 plus 5 is 6. 1 minus 1 is 0. Goodbye, a term. And then b times 2 times 1 is 2. We get 3. B is 2. We get b is 2 very quickly by using substitution there. Now let's let b be negative, x be negative 1/2. You get negative 1/2 by taking 2x plus 1 and setting it equal to 0. So now that's going to cancel out the b term. So x is negative 1/2. So negative 1/2 plus 4 or plus 5 is 4.5. 4.5. And then we get a. That's going to be negative 1/2 minus 1. That is negative 2.5, right? Nope, negative 1.5, sorry. And then how many $50s would it take to make 450? It would take 3. So a is negative 3. So a is negative 3, b is 2. You get the same thing if you set up a system in order to do this. You're going to get exactly the same thing. And if you're like, I don't like that substitution, all right, go straight to the system. It doesn't matter. So from here, children, exactly, okay, we've got the quotient 2x plus 3 plus a over 2x plus 1, so negative 3 over 2x plus 1, plus b, which is 2 over 2x plus 1. This is our full answer here. Did I miss one? Oh, minus 1. Thank you. Boop, boop, boop. There we go. So we've got quotient, and then this is the decomposed remainder broken into pieces. So quotient plus broken up remainder. There you go.